Hello and welcome friends to 5 Minutes Engineering. In today's video, we are going to be focusing on stack operations named push and pop operation, the most popularly used. And now here, with the help of visualization and some of the technical coding details, I'm going to deliver each and every detail of this push and pop operation to you with this video, with the help of this video. So first of all, so there are some basic terms or basic things that we need to understand before moving any further, and these are the three things that are mentioned here. So what are these things? So first of all, we will just pick up the middle one and understand it, what it is basically. So here there is an array that we have considered whose name is stack. So see how the funny situation here is that we are using array data structure to understand the working of stack data structure. Okay, so here the data type of that array is an integer, and we can see the array name is stack. And here, what are the maximum capacity of that particular array? What is the maximum capacity? How much max the number of elements it can accommodate? That is mentioned as a max. And now what is a max? So it is defined here, max equal to 5. That means what? It is clearly indicating us that maximum 5 elements can sit up into your respective array named as stack. Okay, and very important other thing that we have to talk about is this bottom one, that is the top. Okay, actually it is specified in the bottom of these three, but it is named as top because it is indicating or pointing to the top of the stack. Very important thing, top of the stack, because whatever we have to take out of the stack will be the top of the stack element. Whatever we have to insert or put it into the stack, it will become the top of the stack. Okay, so that's the simple point, and this is the variable that we are going to use to point to that particular top of the stack element. So that's the initially top equal to -1. Why we have considered top equal to -1? Why we are taking it here? Because if you see, now see, we have seen the array data structure always in a sleeping mode, in a horizontal mode, but now we have to wake him up. Okay, and now it is standing in a vertical position, which somewhat looks like a stack because we have to see the working of stack. Okay, so that's why the array is standing, and these are nothing but the index values. Okay, 0, 1, 2, 3, 4 like that of a array, and the name of this array is nothing but the stack. Okay, now we have to understand initially the top is equal to -1. Why? Because the stack is empty. Why? Because the stack is empty. Top equal to -1. So as I was saying, top equal to -1 because this stack is totally empty. There is no element in this particular stack. But let's say if there is a element, if we just put it into the stack, one element, let's say, okay, and that element is, let's say, 10. Okay, that element value is, let's say, 10, and it is being inserted into your stack, and now it is at this particular position at the bottom. Okay, so what we are going to do, we are going to simply increment the top by 1. That means -1 plus 1 becomes equal to 0. That means now top value is equal to 0. That means top is actually pointing to this particular 0. Okay, and it is indicating that this is the element which is at the top of the stack with the index 0. I hope you got this simple point. Okay, but if we again take this out, we we don't want any element for now in the stack, so we want it empty. So I just eliminated it. Okay, I just took that particular element out. So what will be happening? So again there would be -1. That means decrementing it, because one element has been gone out of the stack, so we will decrement by 1, and therefore 0 minus 1 become again -1, and -1 indicate that the stack is empty, and you can see actually the stack is empty that way. Simple as that. Okay, now these are the basic things that we have now just understood, the basic terms. And these are the two basic prerequisite functions, we can say, prerequisite things we can say. These are the two things that we need to understand before actually moving to push and pop operation. Okay, and what is that? Is full and is empty. That's the simple thing. Okay, means what? Let's say we have a bag. Okay, we have a simple bag, shopping bag, let's say, and you have purchased many of the atoms. Okay, and let's say you have purchased one more atom, and you want to put it into the bag. But first of all, you have to check, is my bag full to its capacity? Is my bag full to its capacity? What do you mean by full to its capacity? Means even if you put one more object now into the bag will tear down. The bag will simply tear down, and all the purchased atoms will be on the floor. Okay, so that's the maximum capacity. That means it cannot hold on to any single weight that you will be putting into the bag anymore. Okay, so that's the, let's say, overflow, something like that situation would be encountered. The other situation that you could imagine is that you want to just take out some of the atoms from your bag. Okay, but before that we have to check that is there anything in the bag. Okay, if there is anything in the bag, then you can only just take out the thing out of some of the things that are available into the bag. But if there is nothing in the bag, then what you will do? If there is nothing, not even a single atom in that particular bag, then there is nothing to just take out of that bag. So we can say it is empty. Simple as that. So that's what we are going to check in these two particular functions, that is full, is empty. If it is full, then it will return true. If it is not full, it will return false. If it is empty, the stack, not here. So basically the example that we considered as a bag, that bag is nothing but our stack. Okay, if it is empty, it will return true. If it is not empty, it will return false. Simple as that. Okay, so let's see how we are deciding the fact that particular stack is empty or full. Okay, now the condition for is full is mentioned as if top equal to max minus 1. Initially, if we see, top value is equal to minus 1. Okay, and what is max minus 1? Max equal to 5, minus 1 equal to 4. That means when the top value will be equal to 4, then we can say that there is no further space to add or put another element into our stack. Okay, but now it is minus 1. Minus 1 is not equal to 4, so we can say that this is not true. And if this is not true, we will be going to else and returning false. But what can be the situation where it will be true? Simple. If we just put 10, 20, 30, 40 and 50, let's say, like these elements, what I just did now is that I have just filled up my stack to its full capacity. Okay, now what are the events that are happening while I am pushing up these elements into the stack? Simple. See, when 10 has been there, so top value will be equal to 0. When 20 has been pushed into the stack, top value will be 1. When 30, the top value will be 2. When it is 40, top value will be 3. When it is 50, top value will be 4. So now 50 has been pushed into the stack and your top value is equal to 4. Okay, because we are incrementing one by one as we are inserting the elements into the stack. Simple as that. So top value equal to 4. Now let's say I want to again push one element, let's say 60. I want to push this 60 into the stack. Will it allow me? Will it allow me? So I have to check it if it is full or not. Okay, while pushing you have to check if it is full or not. While popping you have to check whether it is empty or not. Okay. Now here you can see here top equal to 4 value is there, and I am just considering this situation or condition again. Top equal to max minus 1. So top equal to 4. What is max minus 1? It is 4. Hence 4 equal to 4. Yes, it is true, justified, and hence it will return true, that yes, it is full. Simple as that. That's how the whole logic is working, and true and false are getting returned as per the condition. Okay, so let's move further and understand this particular part. And here it is mentioned, okay, if empty, let's say this name is not if empty, it's a is empty, because we are talking about is full. Let's say it as a is empty.